We continue to learn Chapter 6, Eigenvalues. Section 6, Quadratic Forms. Part 1, Conic Sections. First, we learn about a quadratic form. Given you a matrix A, we know that if we define fx equals a times x, then this is a linear function. And the quadratic function is like this, fx equals x transpose times a times x. The definition, if we consider a special case, if x is a two-dimensional column vector, if the matrix A is a 2 by 2 matrix, then we call a quadratic equation in two variables, x and y, is defined in this form. A times x power 2 plus 2b times xy plus c times y power 2 plus dx plus ey plus f equals 0. So if you write as a matrix vector form, it's like this. So here is a row vector times this 2 by 2 square matrix times this column vector plus this row vector times this column vector plus f equals 0. So the associated with the quadratic form x transpose a times x. So if you only consider the quadratic terms, so it's ax power 2 plus 2bxy plus cy power 2. You can write the vector bx and the matrix A here. Now we consider conic sections. A conic section is a curve that can be formed by intersecting a cone with a plane. Okay, here we have a cone. Okay, we consider non-degenerate conics. So if you use a plane to intersect with this cone in this position, you will get this one, parabola. Okay, this curve we call it parabola. This cutting plane is parallel to the side of the cone. The standard form of the parallel is like this: x power 2 equals alpha times y, or y power 2 equals alpha times x. Okay, and if we use such plane to intersect with a cone, we can get a circle or ellipse. See here, this one is a circle, this one is an ellipse. So the formula, the equation for this circle is x power 2 plus y power 2 equals r power 2, the standard form of a circle. And here, this one, x power 2 divided by alpha power 2 plus y power 2 divided by beta power 2 equals 1. So this is an ellipse where alpha does not equal to beta. Okay, and if we use such plane to intersect with cone, we can get hyperbolas. See, if you use such plane, you intersect with this cone, you can get this hyperbola. So the equation for hyperbola is like this: x power 2 divided by alpha power 2 minus y power 2 divided by beta power 2 equals 1, or y power 2 divided by alpha power 2 minus x power 2 divided by beta power 2 equals 1. And a conic section is a curve that can be formed by intersecting a cone with a plane. Here we consider degenerate cones. If you use special position, this plane intersect with this cone, you can get only a point. So this is a degenerate conics. And if you use such plane to intersect with this cone, you can get a line, also degenerate conics. And here, if you use such plane to intersect with this cone, you can get two lines, a pair of lines. So this is also degenerate conics. Okay. A conic section is said to be in standard form if its equation can be put into one of these four standard forms. The first one, circle. So we know the circle, the standard form is x power 2 plus y power 2 equals r power 2. So in standard position. Ellipse, like x power 2 divided by alpha power 2 plus y power 2 divided by beta power 2 equals 1. And hyperbola, like this. Okay. x power 2 divided by alpha power 2 minus y power 2 divided by beta power 2 equals 1, or y power 2 divided by alpha power 2 minus x power 2 divided by beta power 2 equals 1. So this is the hyperbola. And the parabola is like here, x power 2 equals alpha times y, or y power 2 equals alpha times x. So a conic section can be translated horizontally or vertically and rotated from the standard position. So in general, in most cases, you can have a conic section with its equations not strictly like this. But after we learn this section, you will know that by using transformation, linear transformation, we can transform those to a standard form like one of this formula. So first we see the translation of conic section. Okay, example 1. Ask you to sketch the graph of this equation 9 times x power 2 minus 18x plus 4y power 2 plus 16y minus 11 equals 0. So having this equation, we first try to completing the squares. So we put this 9x power 2 minus 18x together, and we add this constant here, we plus 9 here. And for y power 2, we also completing the squares, so it's 4. Here is y power 2 plus 4 here, so altogether is 4 by 4, so it's 16, okay? And then minus 11 equals 9 plus 16, because here you add 9, here you add 16. So to make this equation still holds, we have this one. And then we can have this form, right? This one becomes x minus 1 power 2. This one becomes y plus 2 power 2. So eventually we have this equation. And if we let x prime, we define a new coordinate, x prime equals x minus 1, y prime equals y plus 2, we will get this standard form. So here we use translation to get this general equation to standard form for the conic section. Okay, now we consider rotation of conic sections. So consider a conic section rotated from the standard position. Let x be xy and x prime be x prime y prime, and x equals q times x prime, and x prime equals q transpose times x. So here should be transpose, okay? Here is column vector, so we write just like this. And then Q, this matrix is a 2 by 2 matrix because it represents the rotation. So it's the first column is like cosine theta minus sin theta. The second column is sin theta cosine theta. It's like rotate clockwise by angle theta, right? And the Q transpose, if you consider Q transpose is cosine theta sin theta minus sin theta cosine theta. So this matrix, this linear transformation, likes to rotate the vector anti-clockwise by angle theta. Okay, and here we have the general form of the equation. The quadratic equation is ax power 2 plus 2bxy plus cy power 2 plus dx plus ey plus f equals 0, and we write in this matrix form. And then for this matrix A, if we define x prime equals q transpose x, then x equals qx prime, then we substitute here x equals qx prime, x transpose equals x prime transpose q transpose. Then we can reformulate this equation in this form, and also x equals qx prime. Okay, we can get this one, where d prime e prime equals de times q. So since A is symmetric, it is possible to find a pair of orthonormal eigenvectors q1 and q2 that q equals the first column q1, the second column q2, diagonalizes A and simplifies the above equation into this form. So this is lambda 1 x prime power 2 plus lambda 2 y prime power 2 plus d prime x prime plus e prime y prime plus f equals 0. So this equation is much simpler than the original one because the quadratic terms, you only have the x prime power 2 and y prime power 2. Now you don't have the x prime y prime like this quadratic term. And given this type of quadratic equation, it's easy to transform it to conic section in standard form. Okay, see this example. Sketch the graph of the equation 3x power 2 plus 2xy plus 3y power 2 minus 8 equals 0. So we first transform it to this matrix form. You can write here times this 2 by 2 matrix times this xy column vector equals 8. And for this matrix A, okay, we can compute its eigenvalues. We know how to calculate the eigenvalues of this 2 by 2 matrix, right? Just determinant of A minus lambda times identity matrix equals 0, and you get lambda. So here lambda 1 equals 2, lambda 2 equals 4. And then solve the homogeneous linear system A times lambda I times x equals 0. You can get the eigenvectors corresponding to each lambda. Okay, so we have this Q. After this, we know that Q can be written in this form. The first column is this one, Q1. The second column is this one here. So it's just like this matrix, like a rotation matrix, right? Cosine 45 degree minus sine 45 degree, sine 45 degree, cosine 45 degree. So now we need to define the new coordinate vector. After we define this new coordinate vector, we try to simplify the matrix to be a diagonal matrix. So how can we do this? We set xy equals this matrix Q times x prime, y prime, so this vector, okay? And then we can get Q transpose A times Q equals this diagonal matrix. The diagonal entries comes from the eigenvalues. Then the equation of the conic becomes this one. See? Just like 2x prime power 2 plus 4y prime power 2 equals 8. So you can also further transform it in this form. So from this form, immediately you know that this is an ellipse, right? So you can draw the figure here. Before it's like x and y here, and now you use new coordinate vectors. You rotate. If you rotate from here, right, anti-clockwise to x and y, from this position, it's like in standard form from x prime, y prime, right? From x and y, it's not a standard form. Original coordinate system is not in standard form, but from x prime and y prime is in the standard form. So you can draw the figure easily. Okay. Now we consider quadratic equations. A quadratic equation in n variables is one of the form x transpose times A times x plus a matrix B times x plus alpha equals 0. Here, if A is n by n symmetric matrix, then B is a 1 by n matrix. B is a 1 by n matrix means B is a row vector, and X is an n-dimensional column vector. Alpha is a scalar. So the vector function, if we define f of x equals x transpose times A times x, which equals this summation, is a quadratic form in n variables associated with the quadratic equation. So this is also a quadratic form for n variables.